Good afternoon and good morning, and welcome to Climate Central's monthly climate brief. Climate Central is a nonprofit, non-advocacy organization of scientists and communicators. Our team researches, reports, and creates resources to help you understand climate change and talk about it to others. Our content is straightforward and visually compelling, and it includes data to make the links between extreme weather events and human-caused climate change. And today we have a mid-year check-in as we look back on 2026. We will talk about the US and the global indicators through June. Um, we will also be talking about El Nino, in case you're sticking around to hear about that. During the second half of the briefing, Adam Smith is going to join us and talk about billion-dollar disasters. But leading our discussion today, kicking off our discussion, is Dr. Zach Labe. Zach's interests are many, including climate impacts, future scenarios, extreme events, and emerging climate science. He is well known and a highly regarded climate communicator, regularly creating dynamic documents and visualizations to expect all aspects of our changing climate. So now to lead our discussion, Zach.
All right. Thanks for the introduction, Jen, and thanks everyone for joining us today. And we will get started. So like Jen mentioned, today we're going to start off with sort of a mid-year climate review, as well as going over last month's climate numbers, both globally and for the US. Then we'll dive into the questions I know that a lot of people have right now in this growing El Nino, which could be a historic event towards the end of the year. And then we'll have our special feature on billion-dollar disasters, some of the latest numbers and research and a preview of those. And I just want to start off with some quick logistics and a reminder that in addition to these webinars, which are recorded, we also have an accompanying report where you can go and read some of these numbers and some of the data we've been talking about, as well as download graphics, both again for the global and US climate visuals. And these are all available on our website. And after this presentation, we'll also upload a recording to those report pages, which can be useful for sort of state of the climate-like references. And so we'll start off with this month's Climate Moment of the Month, which is a recap of where we are. Somehow we're already the middle of the way through 2026. So I wanted to do a quick check-in of where we are for global temperatures. And we're running so far, it's the third warmest start to the year on record. So that's including those global temperature numbers for January through June. So the graph here on the left is looking at sort of, we call it a horse race, sort of how the average temperature over time for each month is comparing to other years in a climate record. So all of those little gray lines, those are data going back all the way to 1850, which we are well above most of those years. And we're well within the rankings of the top 5 warmest years on record. So we'll be keeping an eye on these numbers, especially as El Nino continues to unfold. So now taking a look at the same type of graph, what are we looking at for the US? Well, it's also been a really warm year for the lower 48, the contiguous United States, where so far temperatures for the January to June period are the second warmest on record for that period, only fallen behind the record warm year of 2012, which was a very anomalously warm spring in particular. So it's been both a very warm year globally as well as here in across the United States. And so now let's take a look quickly at June. What did it look like last month? So this visualization, this map here, is showing those temperature rankings all across the globe, where anywhere in that dark red color means that that area observed the record warm June. So you can see almost all continents observed at least one location with record warm temperatures for the month of June. Globally, it was the second warmest on record for June, the fourth warmest for global land areas, and very impressively, already the warmest June on record for the global ocean areas. So even though El Nino is still developing, already our global oceans are really, really hot. In addition, we can see it was also ranked within the top 3 warmest Junes on record for both the northern and southern hemisphere. Some real highlights here again across the equatorial Pacific there on the left of the map. You can see it was record warm already there across the tropical Pacific. Another highlight is also across northern Siberia. So you can see a big red spot there in Russia. It was a very record warm month with extreme heat, temperatures over 90 degrees Fahrenheit across parts of Siberia, stretching into the Arctic. And so, yes, so one of the areas that really saw unusual warmth last month was actually across the Arctic Circle, especially over land areas. So, areas both in Siberia as well as the Canadian Arctic, parts of those areas had very unusually warm temperatures, making June 2026 the warmest June on record for the Arctic. So, the graph here is showing temperatures for every June since the year 1900. So, we can see that long-term warming trend over time in this really outlier year for the month of June this particular year. I wanted to feature another highlight, just giving a few extreme events from last month. Another highlight was, of course, in Europe. Europe's been observing lots of extreme heat waves associated with those heat dome weather patterns so far this summer. In addition to those heat waves over land, we're also seeing heat waves in the ocean in the form of marine heat waves. So what this is taking a look at, it's looking at ocean conditions at the very end of June. So on the left-hand side, focusing across the Mediterranean and Western Europe. So those are sea surface temperature anomalies. Anywhere in the red color means that that was warmer than normal. And then on the right-hand side, we actually are using one of our tools here at Climate Central. It's called the Climate Shift Index, and it basically can show you what's the change in likelihood due to climate change. So how likely are those sea surface temperatures we're seeing in these particular areas? How likely is that due to a climate change influence? And we can see parts of the Mediterranean Sea, it's over 100 times more likely that those unusually warm ocean temperatures were due to human-caused climate change. So the marine heat wave continues. It's subsided a bit in its magnitude so far in July, but it's still really unusually warm across parts of the Atlantic, stretching into the Mediterranean Sea. And this, of course, has impacts for communities nearby these ocean regions. The warm waters can boost humidity, raising those overnight temperatures or adding humidity in the air and added heat stress. So again, just another area of one of these impressive extreme events from last month. If we now take a look more globally at what ocean conditions look like, here's a map of June, again showing those sea surface temperature anomalies where red areas were warmer than normal, which you can see cover almost the entire globe. So you really have to look closely to find any areas that were colder than normal. Probably the most, outlier colder than normal region was there across the northern Atlantic Ocean. Elsewhere, it's very warm, especially in the mid-latitude regions of both the Pacific Ocean and parts of the Atlantic Ocean. And of course, that thing in the middle there, that El Nino signature, which is that band of really warm ocean temperatures stretching across the tropical Pacific Ocean. And again, it was the warmest global average sea surface temperature on record. And in a lot of those really dark red shadings, those are areas also seeing these marine heat wave conditions, which have really high impacts. And in a recent report we did at Climate Central, we found that 85% of the marine heat wave area occurring recently would not have occurred without that additional boost from human-caused climate change. So if we take a look at all those ocean sea surface temperatures and we average it together to get one value for the global average sea surface temperature, how is it looking now going into July? So each of the thin little lines here represent years since 1982. The blue shading, those are older years. The yellow years are more recent. And there, where we are this year is the bold white line. So we can see this is data up through just a few days ago. And we can see that continuing into July, we are seeing record hot global sea surface temperatures. And again, as you saw from that map, that's occurring over many parts of the globe. It's not confined to just one area. So we'll be keeping an eye on this particular graph through the course of the year to see how long and persistent this record warmth for the oceans continues. So now let's zoom in, taking a closer look at the United States during last month. And so we can see that last month's temperatures are shown here on this map relative to normal, where much of the country was warmer than average, and some of the largest temperature departures were found there across the Southwest, with parts of New Mexico stretching into Utah, seeing a record warm June. We also saw unusually warm conditions in the state of Florida, as well as into parts of New England. So one of the unusually record warm areas was like coastal Massachusetts and Rhode Island from last month. There were a few areas that were a bit colder than normal. That includes parts of Montana and stretching across parts of the northern US, as well as parts of the southeastern United States. So, averaging together, it was the 18th warmest June on record. And in addition, we've seen, as we know, a lot of extreme heat so far in the form of these really impressive heat waves. And so far, 2026 is the fourth highest count for cooling degree days. What that basically means is the amount of demand for cooling for air conditioning. So, it's been a year of temperature extremes that have already brought out those air conditioners in the very beginning of spring, well into early summer. And so, looking at one of the more impressive heat events from last month was actually those overnight temperatures. So, it's really important to keep in mind that even though we're seeing long-term warming for average temperatures, we're seeing even greater warming trends for those nighttime temperatures. They're getting a lot hotter and warming at a faster rate. In fact, looking at much of the US, we've seen summer nighttime temperatures have warmed in over 230 cities that we analyzed by an average of about 3 degrees Fahrenheit since 1970. This visualization here is showing an impressive overnight temperatures that were much warmer than normal across large parts of the US during the middle of June. So the left-hand side is showing temperature anomalies, and the right-hand side is showing that climate shift index, how much more likely those temperatures were due to climate change. And in some areas, many areas, in fact, they were at least 5 times more likely to occur due to human-caused climate change. And so I know that many people are interested in the recent big heat domes across the US, especially the one into the Northeast back around July 4th, and the one more recently across parts of the northern US that's still going a bit. And we will be recapping them in next month's briefing when we talk about all of the July extreme events that we've been seeing. Now, taking a look at precipitation. So, June was fairly unremarkable in terms of the average amount of precipitation across the country, but it did bring some good news. As those of you who have been attending the briefings know that we've been really talking about how dry the start to 2026 has been across much of the United States. And some good news has been that we saw some above normal precipitation in the areas that most needed that rainfall, like across parts of the Southeast, really helping to bring some drought relief to those areas. So we can see it was wetter than average across the central part of the US from last month. Taking a look at the drought monitor, even though we've seen some of that short-term drought relief, it's still dry. Nearly 67% of the contiguous United States is at least abnormally dry or in a drought. Again, the good news here is that that number is down 10% from our last briefing we had. So there has been some drought relief. Again, a lot of that coming from the Southeast drought that was really exceptional during the first half of 2026. Unfortunately, we still see large areas of drought covering most of the western half of the United States, where we are seeing extreme or exceptional drought conditions across parts of the Rocky Mountains. And 45 states are seeing at least some areas with moderate drought or even worse conditions. So, again, we're seeing some relief, some added precipitation, but it's still been a very dry year with many areas seeing both short and long-term drought conditions. If we take a look at another metric that we sometimes consider for better understanding drought, it's called the Palmer Drought Severity Index. And it's basically just a measure of how dry or wet conditions are, looking at things like temperature, precipitation, as well as soil, whether the soils are unusually wet or dry, and their ability to hold water. And so, looking at this metric, we can still see how unusual the dryness is across the lower 48, where we're the second lowest Palmer Drought Severity Index on record for the month of June, only getting close to rivaling the Dust Bowl there in the 1930s. Again, we've been showing this particular index for the last couple months, and we've been very consistently close to those Dust Bowl conditions. So just really highlighting how dry it is, especially over such an extensively large part of the country. Now, I do want to highlight one area that has actually been quite wet. In fact, it's the record wettest start to the year on record for the state of Hawaii. They had a series of very impressive storm systems that brought extremely heavy rainfall to all of the big islands in Hawaii in 2026. This continued into June. June ranked as the second wettest on record. That's what the graphs here in the map are showing conditions from last month. But overall, this has just been a very persistently wet pattern with some of the higher elevations even measuring over 200 inches of rain so far this year. So this is just one area in particular that's been unusually wet. It's also been seeing unusually high ocean temperatures, which might have acted to boost some of that extreme precipitation. So we'll be taking a look closely at those relationships to try to understand that as a potential driver as well. So what about year to date, specifically for the United States? Now taking a look at a spatial view. Again, as I mentioned before, it's the second warmest on record start to the year, the highest since 2012, which was the record. So here, this map is showing temperature percentiles, and I want you to really focus on that the whole US is seeing above average temperatures for the start of the first half of the year. In that dark red color, that's areas that are seeing record warm conditions for the January to June period, which you can see covers a large part of the southwestern United States, covering, for instance, the whole state of Arizona and nearly New Mexico, Colorado, and Utah. So, as many of you know, that's an area that saw a historic snow drought, really driven by those unusually warm temperatures. In fact, if we average across states, 9 states so far have recorded their warmest average temperature. And if we look over the last 12 months as a whole, the last 12-month period is actually the warmest on record for the lower 48. So it's been a very warm period in recent months and really years for that matter. And so we'll be keeping, again, a close eye on this for the rest of 2026. Now, for precipitation, as mentioned multiple times, it's been unusually dry. It's been particularly dry across the south and eastern United States, as well as across the west. We've been seeing, though, the one area that has seen a bit of above normal precipitation has been the central US, stretching anywhere from parts of Texas all the way up through the Great Lakes. One state, in addition to Hawaii, that's had its wettest start to the year has been Michigan. So you can almost see where the storm track has been, where a lot of those storms have brought moisture coming up from the Gulf of Mexico, up through the central US, all the way into the Great Lakes, where on either side of it has been unusually dry. And of course, the Western snow drought was a big story so far this year. So where are we going into the future? We know that this week there's another heat dome across the US with unusually warm temperatures. What about the next 6 to 10 days? So this is an outlook from the NOAA Climate Prediction Center, where areas in red are on the left are showing locations that are more likely to experience warmer than normal temperatures over the next week or so. So we can see that shifting into parts of the Pacific Northwest and again stretching into the Southeast. Now, on the precipitation side of things, on the right-hand side, there might be some good news here, where the green areas are areas that are more likely to see wetter than normal conditions. So we can see potential for some above normal precipitation there in the east. That's parts of those regions that have been seeing that drought. We can also see it across the west, and that's associated with the monsoon. So current outlook is showing that we might experience a more active North American monsoon this year. We're already starting to see that kick off with afternoon and evening thunderstorms across states like Arizona, New Mexico, and that might stretch up into the Rocky Mountains. So that is good news. It might bring some above normal precipitation for the summer months. Some of those areas in like Arizona, New Mexico, they actually get 50% of their annual precipitation from the monsoon. So while that's good news, it is only expected to really bring short-term drought relief, where it might bring temporary relief and wetten some of those soils, maybe even alleviate some of the wildfire conditions in some areas, although dry lightning is always a concern. However, for the long-term drought and for those reservoir levels, as well as the Colorado River, that really relies on that snowpack. So we don't expect to see any big improvement for those drought conditions probably until we get towards next winter and see what the storm track looks like then. So as I mentioned before, we have another heat dome over the country this week. It's very warm across much of the northern and western US. So again, taking a look at those extreme temperatures for the next week out using our climate shift index, where we can focus on how climate change is boosting those temperatures, we can see that this really confined to the western half of the US, where some areas like in Colorado, those extreme temperatures are at least 5 times more likely due to climate change. So again, you can explore this tool to really understand the connection to climate change and the extreme warmth we've been seeing. And so now we'll move into El Nino, where I'm sure there's lots of questions. And as a reminder, in El Nino, what that means, it's a natural pattern of climate variability. It's found particularly across the central tropical Pacific Ocean. It's really associated in particular with warmer than normal sea surface temperatures, and that then those warmer than normal sea surface temperatures actually affect the entire circulation of the atmosphere across the tropics and then extend to affecting other climate impacts around the world. The animation you're seeing here is the latest month of sea surface temperature anomalies and how they've evolved. And so you're probably noticing that everything is red here, and those black boxes really outline some of the key monitoring areas for where we take a look at El Nino. The Nino 3.4 is just the name of one of these really important areas where we monitor how unusually warm the temperatures are for the ocean in that area. So we can see that the reds are saturating there and the scale sort of sloshing around. El Nino is really all about the transfer of heat, both in the ocean as well as into the atmosphere. And we can just see over time, over the last month, those really building ocean temperatures just getting warmer and warmer. And so if we take a look in particular at that little box, that Nino 3.4 box that I said was a key monitoring area, we can see that current conditions there with that yellow line as of data through yesterday is at record high sea surface temperatures in that area. So this is due to both the boost coming from El Nino as well as the long-term climate change trend that is warming the tropics. So those combinations are what are contributing to these record sea surface temperatures, which have been at record high levels since May, really. So we'll keep an eye on this pattern in particular to see how high ocean temperatures get in this important key monitoring region. Looking over closer at the last week, so what have we seen in terms of changes in El Nino and how it's unfolding? So looking at about the last week, we've seen more warming across these key monitoring regions of for El Nino, that Nino 3.4, that bold box there. So that red shading means that over the last week, we've seen warmer temperatures continuing to build in those areas. So what this means in short is that El Nino is continuing to develop. Comparing metrics to some of our past really strong El Ninos, like 1997 to 1998, we're very much right in line with the evolution of sea surface temperatures for this El Nino, all giving us more confidence that a very strong event is likely underway. And so if we take a look at the latest discussion and outlook issued from the NOAA Climate Prediction Center, they said there is now an 81% chance of a very strong El Nino during the months of October to December. This would rank among the largest El Nino events in the historical record going back to at least 1950. So we can see if you've been following these numbers, there's just growing more and more confidence in this very strong event. I do want to point out that oftentimes we hear in the media this term super El Nino. So officially, we don't quite use that term for official monitoring in weather and climate, but a very strong El Nino is basically synonymous with this terminology you've been hearing, super El Nino. And so if we actually break down a closer look at those probabilities for how likely to see a strong and very strong El Nino, these are about as high a confidence as it gets for forecasting the strength of a very strong El Nino. So the bottom of this graph, each bar is looking at a different 3-month periods. So like OND refers to the months of October, November, December. And then what each of these bars are showing is the chance of that particular strength of El Ninos. So we can see again, the peak really being, or the highest likelihood for this, the peak of El Nino being at the very end of this 2026 going into early winter, where we have just really high confidence in a very strong El Nino event. And why do we have this high confidence? Well, we can take a look at those current observations, like I showed you from the current maps of the evolution of sea surface temperatures and ocean heat across this region. We can also look at forecast models. So we can look at models that use statistics. We can use models that use physics. And so I'm showing some of these outlooks here coming from these seasonal forecast models. So the list here in the legend is just what those models are called. And so each of the colors here is sort of the outlook for the ocean temperatures in that Nino 3.4 box, where each model is associated with the colored lines here. So we can see that, again, they all really agree on this strong to very strong event as we get into the fall of 2026. But you'll notice there is still some spread among the models, meaning that the difference in the magnitude, there is still some uncertainty. So we're getting more and more confidence on that a strong or very strong El Nino event is very likely. But there again, there's still uncertainty on its exact evolution, and there's also even bigger uncertainty on what those impacts might mean. So I do want to point out that El Nino, what it's really doing here, and why we talk about it in terms of global warmth, is that it's really redistributing heat. So during El Nino years, a lot of that heat building in the ocean is transferred into the overlying atmosphere. And that's why we often see during El Nino years this boost in global temperatures. But I want to point out, and I'll say it probably multiple times, that really the driver of these temperature records, it's human-caused climate change. So this graphic here is showing the change in ocean heat content from 0 to 2,000 meters below the surface, which we can see since the 1950s is just building and building over time. And that's again due to the burning of fossil fuels, leading to rising greenhouse gases, which trap heat and increase global temperatures. So really the driver here is global climate change, where El Nino is just boosting those odds just a bit for more records. And so taking a look at what do we look at for global temperatures going for the next couple months. So this is predictions coming from those same seasonal forecast models. So what we've recently observed there is on the left. This is for global temperature anomalies relative to the pre-industrial era. And then on the right-hand side is the forecasts. So what we can see is that we're gaining more and more confidence that the global temperature anomaly will continue to rise as we get into the fall and early winter of this year, potentially getting even close to 1.9 degrees above pre-industrial levels right now is the multi-model mean. Now, each of those faint individual lines is showing individual models and their ensembles. It's just sort of a version of each model. So you can see there's a big spread across them. So even though the multi-model mean there is towards 1.9, we can see that there's a huge range in those forecasts for global temperature anomalies, anywhere ranging from at least 1.5 degrees all the way above, 2. So that tells us there's still a lot of uncertainty, but again, really growing confidence that we're probably going to be talking about record high global temperatures by the fall, at least for global temperatures. And so, what does that mean in terms of the ranking for 2026? Well, this is an outlook that's put together from NOAA, from the National Center for Environmental Information, NCEI, where they look at sort of past analogs. What that means is they look at the past trajectories of year to year or month to month variations in global temperature, and then try to extrapolate that going forward into the future to give an exact ranking of where 2026 might fall. So there's the highest likelihood that its ranking is fourth warmest, but I think it's really important to point out that we are now effectively virtually certain that 2026 will at least rank within the top 5 warmest years on record, and there is still some likelihood of that ranking within the top 3. The exact ranking is ultimately going to be determined by El Nino, and given the current trajectory of what could be a historic El Nino event, this might boost temperatures even further. But I do want to point out that 2027 is the more likely, at least statistically, to set a new all-time high for annual global temperatures. But we'll be keeping an eye on this as El Nino evolves. In addition to the global climate connection, El Nino also affects climate patterns all over the world. And so we've been getting a lot of questions whether a particular extreme event, like is this heat dome caused by El Nino? And I want to point out that the climate system's complicated. In addition to El Nino, even though that is a really important pattern of climate variability, there's other patterns of climate variability as well that also can have a big influence on regional climate patterns. And so typically the impacts at different regions around the world are usually largest for this connection during the winter season. So during the summer season, even though El Nino is already quite impressive on those maps I've been showing, it's starting to show up in its effects on sort of the large scale atmosphere and weather pattern, but it's still in its infancy and affecting really global climate. And every El Nino is different. So every El Nino has a different timing, strength, how it interacts with these other climate patterns. And I also want to point out two really important things that are unique about this El Nino, and they relate to climate change. So climate change is boosting temperatures across the tropics, as well as boosting and affecting the climate around the world. So that means potentially that looking at past El Nino events, which didn't have as large of a climate change influence, those impacts might be different now in the future due to climate change, lack of better words, like messing things up. So, the important takeaway message here is that yes, El Nino has really important effects on global climate as well as locally in people's backyards all across the world. But again, making its connections to understand those impacts is challenging, and we'll be doing our best in what the weather and climate space to really understand those linkages. And so our takeaways, El Nino is clearly here. You can see that little map there is showing current conditions for ocean temperatures. And it's really growing in likelihood that a historic event could be well underway this year. I think El Nino is one of the main climate stories of the year. But I do want to continue to state, as I did earlier, that human-caused climate change is the key driver for why we're having record-breaking global temperatures. El Nino is just acting to boost those odds a little bit, but it's really that, again, the burning of fossil fuels and emission of greenhouse gases that is affecting those global warmth that we're seeing. And like I said just recently, every El Nino is different and it cannot explain everything in the climate system, but we'll try to put it all in context to understand those linkages around the world. And so I'll just summarize what we took a look at in this part of the monthly climate brief, where again, as we know, it's very warm globally, where June was the second warmest on record. El Nino odds are just continuing to increase. We're about as confident as we get in this space of forecast seasonal climate prediction. And there's a 97% chance that this El Nino will continue through early spring 2027. So it's not going away, and it's just going to become more prevalent in the climate system. Things are still dry. It's been a very warm and active start to the year across the US. In fact, if you sort of average a lot of those extreme events together using this index called the NOAA's US Climate Extremes Index, it actually was the second highest value on record, really showing how alarming the start to 2026 has been across the country. And looking ahead at the next week, we again see more warmth across many areas of the country. Our next webinar for next month will be on August 19th, and we're hoping to have a special feature talking about climate change and health impacts. And so now I'm going to transition us to the next part of the briefing, which will give you a preview of some of the latest research around billion-dollar disasters. And I'm really excited for Adam Smith to be joining us, who is a senior climate impact scientist at Climate Central, where he has really been the lead for decades in developing and maintaining and expanding this crucial monitoring data set for understanding these costly disasters across the US. And now I'm going to turn it over to Adam.
Hello, everyone. So yes, today for the next 15 minutes or so, to save some time for Q&A, I'll be discussing three key sections about what we're doing with the billion-dollar disaster redevelopment Climate Central. First, we'll talk about new state level and regional level tools we've recently released in the last couple months. Then I'll highlight briefly what our mid-year review, which comes out in 2 weeks on July 29th, what that kind of is trending towards and how that compares to past years. And finally, I'll leave you with some new exciting research we're doing this fall over the next several months, developing for several new types of research, adding and expanding the scope of this historic database and analysis, and then how you can access that data in the future. So as part of Climate Central, climate communications and data analysis of all sorts, of course, tracking trends and impacts from extreme events is important because they have impacts to lives and livelihoods for all of us. And we've seen, unfortunately, too many extreme events in recent decades, in recent years. But to do this analysis, which I also led at NOAA, it requires the best public and private sector data partnerships and methodology approaches to capture this data and present it in a way that's salient and actionable and understandable to others. So since 1980, we've analyzed 431 separate billion-dollar weather and climate events, which I'll highlight, that have impacted all parts of the nation. And we're expanding the scope and the depth of this, actually going down to the $100 million level, which I'll talk about in a bit. Next slide, please. So first, some quick background. I mentioned the public and private sector data partnerships. It's important to note that this continuation and redevelopment of the research we've been doing at Climate Central now for about a year still consists of the same public and private sector data partners, data sets, methodologies, assumptions across all these different weather and climate extremes. And so this table kind of shows you the intersection and the types of partners and perils, different hazard types that we've analyzed. Again, it's consistent and the same as what we had done at NOAA for many decades. So partnerships with the insurance, reinsurance, private sector, of course, and U.S. federal agency data is important, such as from FEMA, from the USDA, the National Interagency Fire Center, U.S. Army Corps of Engineers, the Energy Information Administration, and of course, more granular information is often developed by state agencies and other departments, kind of as ex post disaster reporting. And so the X's denote the intersection between some of these core data partners we've had for decades, and then the different perils at the top. And we have more partners, but those are just some of the key ones I highlighted. But from all this information, what you can see is we capture about 16 different asset classes, including the insured and uninsured losses to damage and damage to assets like homes, businesses, government facilities like schools, libraries, military bases, public infrastructure like roads, bridges, levee systems, even time element losses like business interruption or loss of living quarters while your house is being repaired or rebuilt, damage to vehicles, boats, offshore energy platforms that are often damaged or destroyed when tropical cyclones come through. And of course, damage to agricultural and forestry assets that we have data on, such as crop damage or damage to commercial timber, livestock, etc. So that is the type of assets that we've consistently measured for nearly half a century because the data is homogeneous across space and time. But I always highlight what we are not able to capture, including things like damage to natural capital or environmental degradation. Those are non-market type of assets that, like pollution into the atmosphere with, that's an example of that. And the indirect effects, we don't capture that. We don't capture the mental and physical healthcare related costs yet because of the lack of standardized, consistent data. And finally, the ripple effects, the supply chain effects after a disaster into other regions economically, those are also not captured. So the takeaway is this is a robust, comprehensive data set, but it's still conservative with what is truly lost but cannot be completely measured. Next slide, please. So with that background here, we'll get into the more fun part of this. So we have 9 sections currently in the Climate Central $1 billion disaster website, and you can see them kind of listed here on this slide. The overview, we've got mapping, disaster mapping, risk mapping, time series, and climatological trends. And originally we redeveloped this for the whole nation, but now we're diving down to the state level and multi-state regional level analysis that you can get more granular information. Next slide, please. And here's just a few other sections that you can currently explore. And I encourage you to look at this data. It's very interactive. You can download some of this data. So look at disaster climatologies, summary stats over different times for different states, different hazard types, even individual kind of disaster summaries. And finally, FAQs and references to our annual reports that we've done for more than a decade. Next slide, please. So here's just one section that I was highlighting. This is the disaster mapping portion. So you can see from January 1980 through March of 2026, our first quarter release of this year, this map is the aggregate losses for all the billion-dollar disasters at the state level. And you can see clearly that all of the country has been heavily impacted by many of these extremes over space and time. So Texas, Florida, Louisiana really lead the way as the top 3 states who have had the highest cumulative cost total in the 300 to 450 billion range for each of those. But California, as we've seen unfortunately in recent years, really over the last almost decade, these mega wildfires have really pushed California also in this upper echelon of unfortunately impacts to lives and livelihoods and costs. But you can also see the bottom, Alaska, Hawaii, Puerto Rico, Guam, U.S. Virgin Islands, all these territories, all these states have been impacted by billion-dollar disasters. So you have to know your hazard and understand the data to make future decision making for yourself and your family and your business. Next slide, please. But we have many different filters, many different types or ways to get at the data. Here's another example using a different filter for the same U.S. map from 1980, or excuse me, for a 10-year period, 2015 to 2024. And this is looking at the total costs normalized by each state's annual GDP. And you see the map is a bit different here when you normalize it in different ways. So unfortunately, again, you see Louisiana, because it gets hit by so many types of events and really impactful events like Hurricane Katrina, or Hurricane Ida, or droughts or floods or severe storms. It leads the way. In excess of 5% of its annual GDP on average is wiped away or taken away from uh, in relation to the cost from these extreme events. But many states, including states you wouldn't expect, like even Montana, the impacts from heat waves, droughts, wildfires, um, flooding, severe storms, even sometimes. But again, many parts of the nation are impacted by different extremes, and we try to continually adding different data filters to make this analysis maximally useful for different use cases and decision makers. Next slide, please. So here's what I was alluding to in terms of some new developments we've added to the website at Climate Central, the $1 billion disaster tool, focusing on either multi-state regions or individual state level tools. So here we'll start with the Central Climate Region, and you can see that would constitute Illinois, Indiana, Kentucky, Missouri, Ohio, Tennessee, and West Virginia. That group of states, and that's defined by the NOAA NCI climate regions. We use the same regions as we did at NOAA. And so since we have not yet released quarter 2 data, which will be in 2 weeks, we're just looking at quarter 1. So the little red line there shows for the first 3 months roughly of the year how this central climate region costs stacked up against other years cumulatively, and from January through December, each of the last 47 years, inflation adjusted to present day dollars. And you can see it's in the top 5 there. I mean, that's still a little bit too little data to understand how it ranks with trends. But you can look at other types of lines on this graph. Like, for example, the green line would be back in 2011. That was a really profoundly extreme severe storm season for much of the central and southern United States. Impactful tornadoes, EF5 tornadoes, in fact, the year of Joplin. And you can see how the green line, jumps up from March to April quite profoundly for that multi-state region. Or you could look at the orange line. That would be 1993. That's the kind of the historic Midwestern flood event. It was about a $30 billion flood. Or look at the end of the graphic there, kind of the dark blue line from November to December. It shoots up. What that was is the kind of the historic U.S. drought heat wave, which impacted 2/3 of the nation, but it was really centered on a lot of the states that are in this multi-state region. And so you can just drill down into this and select individual hazard types, multi-hazard types. This is all the hazard types. But it just kind of shows you climatologically how different extremes have played out over space and time. Next slide, please. So let's actually look at a subset of that previous graphic. This is actually Illinois just by itself as a state. Again, each of the last 47 years from 1980 through 2026. Again, the red line is this year, the first quarter of this year. And you can see Illinois, as you'll see in a couple of weeks on some of the new maps we're developing now, has really unfortunately been kind of the epicenter geographically of a lot of tornadoes, a lot of severe weather for the first half of the year. And even before the last 3 months we are added to this chart, you can see even through the end of March, the state of Illinois had about $1.5 billion of damage, which is in the top 3, inflation adjusted. But you can see the same historic trends for Illinois jump out just like it did for the multi-state chart. So the 1993 green line for the flooding, or the dark blue line for the drought heat wave in 2012. So just some other examples of tools that you can really interrogate the data a bit more closely. Next slide, please. And again, another tool on the website. This would be, again, for the central climate region, that 6 or 7 state region. You can see how cumulatively, for the full period of record, the costs in terms of frequency, average cost, total costs, how that compares to other states or regions. So unfortunately, the central climate region, as you can see, pretty much gets all the extremes. Severe storm events at 158.6 billion are the driver, which shouldn't be a surprise to most people who study weather across the United States. But drought, the impacts of drought and the climate impacts are quite profound, coming in second place at 65.6 billion. But winter storms, flooding, even tropical cyclones, hurricane impacts as they go inland, can impact some parts of that region. So again, another new tool we've developed in the last several months. Next slide, please. One more tool I'll show you, just the climatology. So this is a totally different region. This is the U.S. Southeast. So I don't think I put the states on here, but it's in a 6 or 7 state region. And what you can see from this chart is that really it's kind of a tale of two seasons in terms of the extremes across the Southeast. The dark blue color is the severe convective storms. So that would include tornado, hail, high wind type impacts for billion-dollar disasters. A little bit of flooding events in the green, but you can see that the spring is primarily in the Southeast driven by severe convective storm damage. But then that flips when you get into the late summer, early fall, when, of course, the impact from tropical cyclones are quite profound, as we've seen in recent years. But even wildfire impacts do happen in the Southeast, not quite to the magnitude as what we see on the West Coast, but they do happen. But one kind of commonality, as we've seen this year in 2026, is the drought. Drought is January through December and through different intensities. And of course, it's more amorphous as far as how it changes in space and intensity and impact. But the U.S. Southeast from this data, from this graphic, shows how indeed drought is, really impactful. And of course, a lot of agriculture exists in the Southeast, so we have to take that into account. Next slide, please. So kind of jumping ahead to what we'll be releasing in 2 weeks on July 29th. This is kind of a quick projection for the full United States. The red line is kind of the high-low projection for the cumulative cost for the first 6 months. It's roughly between 25 and 35 billion, kind of hedging a little bit towards a higher number of that one. And you could see it. It's in about the top five. It's not been a record-breaking historic year yet, but it's definitely been active with severe convective storms. We've had a few winter storms, even a crop freeze event in Florida. And so there's, as you'll see in some of our release information in a couple of weeks, it has been quite active across the United States. Next slide, please. And so this is the same setup, except for this is looking at the frequency, the count of these billion-dollar disasters. So right now our range is between 10 and 13 separate billion-dollar disasters for the first 6 months of 2026. And as I mentioned in the previous slide, not record-breaking in terms of cost or frequency, but certainly it's quite high compared to all the other years, inflation adjusted. And so you'll see a little bit more data on that. So we're still compiling the numbers and doing the analysis right now. Next slide, please. So to wrap things up, here are some pretty exciting new developments. After we release our Q2, our mid-year update here in 2 weeks, we'll get right back into the development that's been going on for several months, which includes kind of a full scope reanalysis down to the $100 million level. So a whole order of magnitude going down to capture the small and medium-sized disaster events that we've never done in this analysis in this data set. So I think that's going to be a really impactful and helpful way to better capture trends over space and time. We're also kind of redoing the approach to how we quantify wildfire impacts in the United States. So from 1980 to present, we're going to reassess all of the wildfires that are $100 million individually or higher. So, as opposed to the more aggregate wildfire season regional analysis we had done at NOAA for many, many years. So I think, again, adding granularity and depth and scope to the data is kind of the point of why we're doing these projects, because it allows people to understand their risk more acutely. And finally, one thing we'll get into, this might actually wrap into the first quarter of 2027, would be partitioning severe convective storm events by their primary versus secondary damage drivers. So, a lot of severe convective storm events are combinations of tornadoes, hailstorms, and wind or even derecho type events. But kind of adding a little bit more detail and trying to discern how the trends for these sub-perils kind of are changing over space and time would be another kind of addition to this data set. And ultimately, all of this kind of feeds back into like a lot of what Zach was presenting and many other people at Climate Central. There's a lot of different programs and research and focus areas to try to show how weather and climate extremes are impacting people, society, business decision making. even impact event attribution research. So a lot of this new research for billion-dollar disasters will feed back into other programs and other work that's being done to augment and enhance what we're currently doing.